geometry students. Today's lesson is going to be about finding the areas and perimeters of quadrilaterals and triangles. And y'all will remember that a quadrilateral is a four-sided polygon. So on our first page of notes, we are going to begin by focusing on the shape called parallelograms. You can see a picture of a parallelogram here, and what you need to know is that any side of a parallelogram can be called the base. So often we think of the base as the bottom side, but if I turn my paper sideways, the bottom isn't the bottom anymore, and now I could say the side is the bottom. So technically any side could be considered to be the base. The height of the parallelogram is going to be the perpendicular distance between any two parallel bases. So when you see this right angle box, that's going to help you to find your height. Your height always needs to have a right angle box marked on it because it is a perpendicular distance between the bases. So to find the area of a parallelogram, we multiply the base times the height. So here's your area formula. That is also on your geometry formula chart, so you can use that to refer to. The geometry formula chart is attached in Google Classroom, and you're allowed to use it throughout this unit. You may also use a calculator. Okay, so let's do some example problems. Number 1, the directions say find the perimeter and the area of each parallelogram and round to the nearest tenth if necessary. So on problem number 1, we are going to remember our formula. This is a parallelogram, so the area formula is base times height. And so first thing we want to do is figure out how long is our base. Well, this side here on the bottom has 8 feet marked from the left vertex until this height line, and then 10 feet beyond that. So we would add those two measurements together. 8 plus 10 gives us 18. So area equals 18 for the base times the height is marked with the perpendicular, the right angle distance between these two parallel sides, the bases. So that's going to be 16. And then 18 times 16 is equal to, feel free to use a calculator, 288. And the units here are going to be for area measured in square units. So feet with the little 2 at the top for squared. Okay. All of our areas are measured in square units because that is describing how many 1 foot by 1 foot squares it would take to completely cover the shaded part of our parallelogram, the surface there. So we found our area, but it says to find both the perimeter and the area in the directions. So now we're going to work on finding our perimeter. We know that the bottom and the top are both 18, and to find the perimeter we add all the sides. So we can do an 18 plus an 18 for the top and the bottom. But we also need to know how long the left and the right sides are, and they did not provide us with that measurement. So we're going to have to use this right triangle here and our Pythagorean theorem that we learned earlier this year to find the missing measurement for the hypotenuse, the longest side, opposite the 90-degree angle of this right triangle. So it's going to be a squared plus b squared equals c squared. And the a and b sides are the legs, the two sides that touch the right angle. 8 squared plus 16 squared equals c squared. And if you add 8 squared plus 16 squared, you get 320 equals c squared. Then to get that c by itself, we have to get rid of the square. To undo a square, we take a square root. So take the square root on both sides, and c is equal to It's a decimal. Notice in the directions it said round to the nearest tenth if necessary. So the tenth would be one number after our decimal. So if you do the square root of 320, you will get 17.9 approximately. So we're going to add 17.9 for the left side, and then opposite sides of a parallelogram are congruent. We learned that in the fall semester. So plus 17.9 again. And then if you add all of those measurements together, your total perimeter comes to 71.8. And perimeter is not measured in square feet. Perimeter is the linear distance around the shape, like if you were to actually just measure that out with a ruler. So it would just be plain old feet. And all of our perimeter measurements will be in linear units, so no squares on those. Okay, let's move on to number 2. For number 2, we're going to find the perimeter and the area of this parallelogram. Notice the tick marks on all the sides. We know that all the sides are congruent here, and they are all 24 inches. So the perimeter should be pretty easy to find. We could do that to start. We can just add 24 plus 24 plus 24 plus 24, or 24 times 4, and that's going to give us 96 inches. So that was the easy part here. Now we'll do the area. The area again is base times height for a parallelogram. So now we know the base is 24, but we don't know the height. They have it marked here with a dashed line, and the right angle, but we don't have the measurement here on the height in the parallelogram. We do know that this angle is 60 degrees, and opposite angles of a parallelogram are congruent. We learned that back in December. And this hypotenuse of this special 30, 60, 90 right triangle is 24 because all the sides are congruent. So if you will remember, we have to find the length of this height. This is called the long leg of this 30, 60, 90 triangle. Since we're given the hypotenuse, the short leg is half of the hypotenuse. So half of 24 gives us 12. And then the long leg is going to be the short leg times the square root of 3. So 12 times the square root of 3 is the height. And if you wanted to type that in your calculator and get a decimal, that would be approximately 20.8. So the special right triangle pattern for the 30, 60, 90 triangles is found on the formula chart, also in Google Classroom. So you can refer back to that if you need to remember that. So our area is going to be the base, which was 24, times the height, which is 20.8 that we just figured out. And that gives us 499.2 inches squared. So next, number 3. We have another parallelogram. We know the bottom side is 30. That means that the top side is also going to be 30 because the opposite sides are congruent. The left is 15. The right is going to also be 15. And that means our perimeter is pretty easy to find. We just add 30 plus 30 plus 15 plus 15, which gives us a total of 90 feet. Now we need to find the area. The area formula is base times height. Our base is 30, and our height is this perpendicular distance between them. Again, they did not give us the height. So our opposite angles in a parallelogram are congruent. So this one is 45 degrees also. And if you remember from our special right triangles, that you have a pattern for a 45, 45, 90 special right triangle. And that pattern is that the hypotenuse is equal to the leg, which these two legs are congruent, times the square root of 2. So if they gave us the hypotenuse, we can get the height by taking that 15 and dividing it by the square root of 2. Remember, we divide to get the smaller side, we multiply to get the bigger one. So our height is going to be equal to approximately 10.6. So we multiply here by 10.6. 30 times 10.6 will be our area. So let me scoot that over. So 30 times 10.6 gives us 318 square feet. Okay, let's scoot on down and work on some triangle problems. So for the area of a triangle, you're going to use this formula, 1/2 times the base times the height. Or you can do base times height divided by 2, which means the exact same thing. Now you need to keep in mind your height and your base have to be at a 90-degree angle to each other. And occasionally that means that your height is going to be outside of the triangle. So we'll do an example where we look at that. In these problems that we are given to work, they ask us to find both the perimeter and the area of each triangle. Whoops. Just trying to tighten this so it doesn't wiggle. So what I want you to keep in mind here is that when they tell us to find the perimeter and the area, they're asking us to do that for the shaded triangle. So you'll see that we have some little triangles sometimes drawn with dotted lines outside. That's extra information to help us solve the problem, but that's not actually what we're using as our triangle. So on number 4, we're finding the perimeter and the area of this shaded triangle. Whoops, we know that the base, it's not cooperating, I apologize, is 15. And we need to know the height, which is right here, this perpendicular line coming up from the base. We do not know how long it is, but they gave us this little dashed line triangle out here to help us. We know this one has a leg length of 3 and a hypotenuse of 5. Some of you may remember that there's a Pythagorean triple with a leg of 3 and a hypotenuse of 5. And if you do, you probably could tell me the height very quickly. If not, that's okay. We can use Pythagorean theorem to find that missing height. So we would go a squared plus b squared equals c squared. 3 squared plus b squared equals 5 squared. The hypotenuse is the longest side across from the 90-degree angle. So 9 plus b squared equals 25. If you subtract 9 on both sides, b squared equals 16. And then take the square root on both sides, b equals 4. So this height is 4. It's the good old 3, 4, 5 right triangle. So to find the area of this triangle, we're going to do either 1/2 or 0.5 times the base, which is 15, times the height, which is 4. And when you multiply that together, you're going to get 30 square centimeters. And now we also need to find the perimeter. To do the perimeter, we're going to have to do the Pythagorean theorem a second time because we don't know the hypotenuse of this right triangle. So I'll do that over here on the bottom corner. We have 4 squared plus 15 squared equals c squared. And 4 squared plus 15 squared is 241. And then we take the square root on both sides to get c by itself. And the square root of 241 is 15.5. So this missing side is 15.5. And now to do the perimeter, we add 15.5 plus 15 plus 4. And that equals 34.5 centimeters. Okay, so for number 5, we again are finding both the perimeter and the area of this triangle. Let's do the area first. I think we have all the information we need for the area. Area is 1/2 times the base times the height, and the base is 22. And the height is the perpendicular distance from the line containing the base to the opposite vertex. So this is an example of a problem where the height is actually outside of the triangle. Because if you take the line that contains the base and extend it to go at a 90-degree angle to the opposite vertex, you have to be outside of the triangle. So 16 is the height of this triangle. So 1/2 times 22 times 16 gives us 176, and then it's square feet for the unit. And now we're going to try to find our perimeter. We know the bottom side is 22. We know this longest side is 34, but we do not know this left side of the shaded triangle. We have this right triangle here on the side that we can use to help us find it, though, with the Pythagorean theorem. So the two legs that touch the 90-degree angle are 16 and 8. So we'll do 16 squared plus 8 squared equals c squared. And 16 squared plus 8 squared is 320. And then we're going to take the square root on both sides to get c by itself. And the square root of 320 is 17.9. So for our perimeter, we're going to go 17.9, which is this side right here, plus 34 plus 22, and that gives us 73.9 feet. Okay, number 6, we're going to do the area is base times height divided by 2, or 1/2 base times height. So 1/2 times our base is 13, and our height is that perpendicular distance from the line containing the base to the opposite vertex, so that's 9. And 1/2 times 13 times 9 gives us 58.5 square feet. Oops, sorry. And then the perimeter we have to do, the perimeter is challenging on this one. First, we only know one side, the bottom side of this triangle. We don't know the right side and we don't know the left side. So we actually have to do Pythagorean theorem twice to find those missing sides. So let's do this right side first. We'll go 9 squared plus 9 squared equals c squared. So let's see, 81 and 81 makes 162. And then we're going to take the square root on both sides. The square root of 162 is 12.7. So this side is 12.7, rounded to the nearest tenth, of course. And now we'll find this long left side of the triangle, again using Pythagorean theorem. So we're focusing on the right triangle that goes down all the way over and across to do the Pythagorean theorem to find this big long hypotenuse of the large right triangle. So it's going to be 9 squared plus, what is 13 plus 9? That's going to be 22 squared equals c squared on this one. So 9 squared plus 22 squared equals 565. And then we take the square root on both sides. So the square root of 565 is 23.8. So this is 23.8. So we're going to find our perimeter by adding 23.8 plus the bottom side 13 plus the right side 12.7, which equals 49.5. Oh, these units are centimeters. I apologize. I wrote square feet on the area here, but it should have been square centimeters. Okie doke. Now we'll go and do some problems with trapezoids. So, area of a trapezoid. Here is our formula for the area of a trapezoid. It looks kind of like the area of the triangle, 1/2 base times height, except for instead of having one base, we've got two bases added together. So it's the parallel sides of the bases, so we're going to add them together, and oops, put it on the side there. And then we're going to multiply it by the height, and then you can either multiply times 1/2 or multiply times 0.5 or divide by 2. All of those would be equivalent. So on the bottom, these say to find the area of each trapezoid. It does not ask us to find the perimeter this time, so just the area. So we'll start by writing the formula. 1/2 times the height times base 1 plus base 2. And we'll fill in what we know. 1/2 times the height is the perpendicular distance between the bases, so that's 16. And then the two parallel sides are the top and the bottom on this one. So we add those together, 32 plus 18. And this gives us an area of 400, and the units are square feet. Okay. Number 8. Area equals 1/2 times the height times base 1 plus base 2. So our height is this perpendicular distance between the lines containing the bases. So that's going to be 28. And then we have our bases 12 plus 24. Notice on the number 7, the bases ran horizontally, and on number 8, the bases run vertically. So it's not always going to be the top and the bottom side. What you're looking for are the parallel sides, and those should be marked with arrows, or if it tells you that it's a trapezoid and it's apparent which sides are parallel, you'll use those. Okay, so now we're ready to work this out. Feel free to use a calculator, of course. And this one is equal to 504 square yards. All right, number 9. Area equals 1/2 times the height times base 1 plus base 2. 1/2 times the height is that perpendicular distance between the bases, so that's 5, times 8 plus 15, the parallel sides are 8 and 15, and this comes to 57.5 square inches. All right. The very back, this is the last of it, is finding the area of a rhombus or a kite. Now, in the picture, you can see a rhombus here and a kite here. These shapes are not the same, but the neat thing is the rhombus and the kite share the same formula for area. 1/2 D1 times D2. And if you look at the picture, D1 and D2 are the lengths of the diagonals connecting opposite vertices of your either rhombus or your kite. So let's go down and practice with some of these. These again just say to find the area, not the perimeter. So on number 10, we can see we have a kite. So we're going to use our formula. Area equals 1/2, or you can use 0.5, D1 times D2. So it doesn't matter which diagonal you call D1 and which diagonal you call D2. Just make sure you use both measurements. Area is 1/2 times. Diagonal 1 we could say is this short one. 20 added to 20 is going to give us 40 for that length. And then D2 we could say is this long one. 56 plus 26 equals 82 for the length of the longer diagonal. So we do either 1/2 or 0.5 times 40 times 82. And that gives us 1,640 inches squared, or square inches. All right, number 11. On number 11, we're looking at a rhombus, and so the area is going to be equal to 1/2 of D1 times D2. And we're going to find the length of diagonal 1. Let's say I use the shorter one for diagonal 1. This side is 10. There's a tick mark over here. This side is congruent. It's also 10, so 10 plus 10 gives me 20 for the length of that short diagonal. Now the long diagonal has 20 on the left side. There's double ticks here. The opposite one will also be 20. If y'all will remember, we had a property of a rhombi that said the diagonals bisect each other and they meet at a 90-degree angle. So we see a reminder of all that important stuff we learned earlier this year. 20 plus 20 gives us 40. And now we multiply. 1/2 times 20 times 40 is equal to 400 centimeters squared. All right, on number 12, we see a square. And a square just happens to also be a rhombus, a special rhombus where the diagonals are congruent. So we're going to go area equals 1/2 D1 times D2. So diagonal 1 would be 13 plus 13, which would give me 26. And then the other diagonal is congruent, so it's also 26. So the area is 1/2 times 26 times 26, which gives us 338 square centimeters. All right. Number 13, this one is a kite. So we use area equals 1/2 D1 times D2. 1/2 times diagonal 1 would be 18. Diagonal 2 could be 12, or the other way around, it doesn't matter. 1/2 times 18 times 12 equals 108 centimeters squared. All right, now we get to the fun, the algebra problems. On number 14, we have a trapezoid. They tell us the area, which is different because we've been calculating the area on all the previous problems. They tell us the lengths of the two bases, and we're being asked to find the length of the height. So on these types of problems, my first recommendation to you is write down your formula. Identify the name of the shape, it's a trapezoid, and then write down the area formula. So the area for the trapezoid is 1/2 height times base 1 plus base 2. Then your next step is going to be to fill in all of your known information. They tell us A equals 164, so I'm going to take out the A and substitute 164 in its place. 1/2 is a given. The height is my X. That's what I'm trying to find. Base 1 and base 2 are the parallel sides, Again, those can be switched. It doesn't matter which one goes first and which one goes second. So we'll say 12.8 plus 20. And now we're going to use our algebra skills to solve for x. If you add 12.8 plus 20, we're working in the parentheses first, we're going to have 32.8. Now, if you'll remember, multiplication is commutative, which means you can multiply in any order. So I'm going to go ahead and multiply 1/2 times 32.8. And 1/2 times 32.8 gives me 16.4. And now, to get the x by itself, since it's being multiplied by 16.4, to undo that multiplication, I'm going to divide both sides by 16.4. That will get my x alone. 164 divided by 16.4 is 10 feet. Okay, last one. First, we want to identify the name of the shape. This is a kite. Then we want to write down the formula for the area of a kite. 1/2 d1 times d2. Then we want to fill in the known information. We're given that the area is 247.5. 1/2 is part of the formula. D1 is 22.5. And D2 is my x. I'll just put an x there. That's what we're trying to solve for. So now I'm going to multiply 1/2 times 22.5. So 247.5 will equal 11.25. And then to get the x by itself, I divide both sides by 11.25. And so x is equal to 22 millimeters. All right. So that concludes our lesson on finding the areas of quadrilaterals and triangles and perimeters also. You have your homework posted, and so if you have any trouble, be sure to ask for help, and good luck. Have a great day. Hope to see you soon. Bye.